All right, let's take a look at absolute configuration and how it's indicated in the nomenclature of alkanes. If you have a chiral center, you simply indicate its configuration R or S at the beginning of the name in parentheses. But if you have multiple chiral centers, multiple asymmetric centers, you have to indicate the configuration for each one and also its location. So 2-bromo fluorochlorohexane has two chiral centers. At carbon 2, the configuration is R, and at carbon 4, it is S for this particular stereoisomer. Of course, two chiral centers, you could have four stereoisomers, four combinations. So let's say we needed to draw the enantiomers of 1,3-dibromobutane and label them and name them. There is one chiral center in this molecule. There are two bromines, but the one on carbon 1, that location carbon 1 is not an asymmetric center because it has two hydrogens. The one on carbon 3, that bromine is located on a chiral center. So the groups are a hydrogen, a methyl, bromine, and a 2-carbon chain with a bromine on the second carbon. So the priorities, bromine will be the top priority, hydrogen will be the low priority, this will be the second high priority, this will be the third. 2 carbons, it's a tie, but the one group has a carbon and 2 hydrogens, the other has only 3 hydrogens. So the carbon beats a hydrogen, makes it higher of the two. So how would we draw the configurations? Well, we can draw a tetrahedral atom, and we place the 4 groups just randomly and see what we get. I will put group 4 priority in the back because that makes life easy. Put the bromine up here. I'll just randomly pick locations. That's 1, 2, 3. And 4 is back where we want it. So what I drew here was S 1, 3 dibromo butane. And if I wanted to draw the other one, well, I just switched two things. So I could have this be CH3 here. Coming forward, it could be the CH2, CH2Br. And that would be the R configuration. You've just heard me say the R enantiomer or the S enantiomer. People do that. I do that a lot. But you have to be careful. If you have a molecule like 2-bromo pentane, it has one chiral center, and that chiral center can be the R configuration or the S configuration. And that's actually what we are describing when we say R or S. What configuration 3-dimensionally is occurring there. We also sometimes say the R enantiomer or S enantiomer. And That's okay if there's only one chiral center, because when you have one chiral center, you have two stereoisomers, two enantiomers. When you have multiple asymmetric centers, multiple chiral centers, you can't really say the R enantiomer or the S enantiomer. You really have to remember that R and S describe the absolute configuration. That's what you're talking about. So, for example, 2-bromo 3-methyl pentane has two chiral centers, and in the case that's drawn here, it's R at carbon 2 and S at carbon 3. But how many stereoisomers are there? There's four. There are four possible configurations, two pairs of enantiomers. And so you can't really say the R enantiomer or the S enantiomer.